Welcome to tonight's video on continuity. So, a function is considered continuous if when you draw the graph, you do not pick up your pencil. So for example, here, if you notice, I'm drawing the graph, but then I have to pick up my pencil to go to this point and then continue on. So this function is not continuous at that point at which I have to pick up my pencil. So that's why it is not continuous at 2. All right, so we say it's discontinuous, and what type of discontinuity it is we'll talk about later, but this is a removable, and I'll talk about how you tell the difference. So it's continuous on the interval from -infinity to 2, from 2 to infinity. So if we talk about the domain of the function is all real numbers, because this dot here fills in the open circle. So domain is all real numbers. Now the limit as x approaches infinity of the function, meaning the right-hand limit, well, it's going towards -infinity. The limit as x approaches -infinity of the function, meaning the left-hand limit, is -infinity. The limit as x approaches 2 of the function, meaning from the left and the right, notice, so as I go from the left, it approaches 4. As I go from the right, it approaches 4. So therefore the limit of the function is 4. Now what is f of 2? F of 2 is 2. So notice this is a removable discontinuity because the limit is one thing, but then the value of the function is another. So that is a removable discontinuity, otherwise known as a hole. So the second one, if you notice here, notice when you draw it, you get to this point here, and then you pick up your pencil and go down to here and continue. So notice it has a discontinuity at 2, but this is a jump because you go from one part to the next part of the function. A hole is where it would just continue on the other side. It is continuous at the same interval, -2 to 2. The domain of G, it is still all real numbers because notice when you get to here, this dot fills that in. The limit as x approaches infinity of the function, well, notice it's going towards 0 here. Actually, sorry, it's going this way, so it's going towards infinity. And then the limit as x approaches -infinity of the function, it's going towards -infinity, meaning the left-hand limit's going down. The limit as x approaches 2 of the function, well, now we have to find the left and right-hand limit because we're looking at it graphically. So if we look at the left-hand limit, it goes to 5. The right-hand limit goes to -3. So therefore, the limit of the function as it approaches 2 does not exist. The reason why is the limit from the left does not equal the limit from the right. And this creates what's called a jump discontinuity because the limit from the left and right are different. So therefore, you have to jump from one place to the next. The next type of discontinuity is what's called an infinite discontinuity. That is when you have a vertical asymptote and the left and right hand limits are infinite. So if you notice here, the domain of the function is all real numbers except 2, because 2 is a vertical asymptote. The limit as x approaches infinity of the function is it's going towards 1, and the limit as x approaches -infinity of the function is also 1. That means there's a horizontal asymptote at 1. And then the limit as x approaches 2 of the function, and remember, when you get to a number, you have to do the left and right hand limit when you're looking at it graphically. So the left hand limit is going towards infinity and the right hand limit towards negative infinity. That means that the limit as it approaches 2 does not exist because of unbounded behavior. H of 2 is undefined. I think I skipped here. I forgot to find G of 2. And G of 2 here is negative 3. So definition of continuity. To see if it's continuous at a point, 3 things have to happen. The limit exists at that point. The value of the function exists. And most importantly, after those 2, is that the limit of the function and the value of the function are the same. So if those 3 things do not occur, then you have a discontinuity. A non-removable discontinuity, it is jump discontinuity if the limit of the function does not exist because the limit from the left does not equal the limit from the right. That gives you a non-removable jump discontinuity. It is an infinite discontinuity if the limit does not exist because of unbounded behavior. It is a removable discontinuity if the limit of the function exists, but the limit as it approaches that number of the function does not equal the value of the function at that point. So those are the 3 types of discontinuity. 2 of them are non-removable, the jump and infinite, because that means the limit doesn't exist, and removable discontinuity is when the limit exists. So now we're going to make a table. When you complete a continuity problem, you're going to have a table, all right? And the values of you're going to have the headings, the limit from the left, the limit from the right, and the limit of the function at that point, the value f of c, and then is the limit the same as f of c? And if it's the same, then that means it's continuous or not, depending upon your answer to the previous one, and what type of discontinuity. So when you make your chart, you're going to have to make the headings. Okay, so once you make the headings, and I filled them in quickly, then you put the problem number, and then for the value of c. So for example, for 0, the limit as x approaches c from the left. So from the left of 0, well, 0 is not a changing point here. So 0 falls in the less than or equal to 2 category. And from the left and right, it is 0. Because the value of the function when you put it in is 0. F of c is also 0. So is the limit equal to the value of the function? Yes. Is it continuous? Yes. There is no discontinuity. For 2, now 2 has different rules from the left and the right. When it's less than or equal to 2, that's the left, it is 2 squared, which is 4. When it's greater than 2, it is going to be 5 minus 2, which is 3. The limit as it approaches 2 does not exist because the limit from the left and right are not the same. The value of f of c is 4. It is not the same. It is not continuous. And because the limit doesn't exist, because the left and right hand limit are not the same, this is a non-removable jump discontinuity. When you put in 3, 3 has the same rules from the left and right. So therefore, you can just put from the left, it is 5 minus 3, which is 2. From the right, greater than 3, it's also 5 minus 3, which is 2. That means the limit as it approaches 3 is 2. The value of the function, however, is undefined because there is no f of 3. Therefore, it is not continuous, and it's not equal. It is what's called a removable discontinuity because the limit exists, it's just not the same as the value of the function. All right, so number 5, you look at the graph. Now let's do the headings first. Okay, so there's the headings. So now for the value of c of negative 3, you look at the graph. All right, so negative 3 is here. Notice from the left it's positive infinity. From the right it's negative infinity. That means it doesn't exist here because it's unbounded behavior. F of c is undefined. The limit and the value function are not the same. It is not continuous. It is a non-removable infinite discontinuity because it's a vertical asymptote. All right, next value is 0. At 0, notice from the left it goes to 0. From the right it goes to 0, so the limit is 0. F of 0 is 0. Yes, it is the same. Yes, it is continuous. There is no discontinuity. The next one is 2. From the left at 2, it goes to infinity. To the right at 2, also infinity. F of 2, the limit does not exist because it's a vertical asymptote. It's undefined. No, it's not the same. No, it's not continuous. And when it's a vertical asymptote like that, it's non-removable infinite discontinuity. All right, the next value is 3. And if you look at the value of 3, from the left, it goes to negative 1. From the right, it goes to negative 3. That means it doesn't exist. F of 3, well, the dot is at negative 3. No, they are not the same. No, it's not continuous. And this would be a non-removable jump discontinuity because the limit from the left and right are not the same. The next value is 5. And if you look at 5, the limit from the left is negative 7 and the right is negative 7, but the value of the function is 1. So the limit is negative 7, but the value of the function is 1. Is it the same? No. Is it continuous? No. But since the limit exists, but it's not just the same as the function, it is a removable discontinuity. And at 7, if you look at 7, from the left it goes to negative 3, to the right negative 1. That means it does not exist because the left limit and right are not the same. It is undefined because they're both open circles. No and no. And this is a jump. Whenever it doesn't exist because the limit from the left and right are not the same, it's a jump. All right, that completes our discussion of continuity. I hope this helps, and you have a good evening. Go Patriots!